as we get to our final notes of the year here, we are gonna we're gonna go strong. We're bringing applications in. Okay, this did not print out as well as I liked it, so I'm just gonna copy over that. That's to be H. You're like, what's O? Not that. No, H sub O. It's a way we label things, and so you're going to be given this equation. You have it here. You'd be given it on a quiz or a test as well. But let me explain what a couple of these things are. The ones labeled, initial velocity. So like if I have a baseball, for instance, and I go and I throw it, when it comes out of my hand, however fast it's going, that's the initial velocity that would be of that. So that's what that part is. This H sub O on the end here is going to be the starting height of whatever your object is. So let's say you're on top of the roof. I don't know why you're there, but hey, you're on top of the roof and you throw something off of it. However high you are on the roof would be your starting height, okay, where that's going to be. The last thing we're going to label is going to be, if my pen works, there we go. Is the height wherever your object ends. Now, if that height at the end is the ground, your capital H is going to be 0 because I can't, well, I could go lower than the ground if I dug a hole, I guess. But typically, if something's moving and it hits the ground, that's as low as it can go. So you're like, what's this negative 16 thing? That is gravity. Gravity itself pulls us down, keeps us on the earth instead of floating around like you would out in outer space. And that negative 16 is the weight that keeps us pushed down. That never changes. That's why we don't put a label on it, because it's always going to be negative 16. So all we have to do is substitute in on these equations the initial velocity, the v sub o, and the initial height, the h sub o, into the equation, and then let the calculator do all the heavy lifting. So, first one, a tennis ball is dropped from a height of 213 feet. There is my initial height, my h sub o. How long does it take for the ball to hit, the ground? My big H, my ending height, is 0. So, here, and this is the part that gets kind of interesting. You're like, okay, so my H sub O is 213. Well, Hardy, V sub O is velocity. It didn't tell me. It's like I dropped it. If I dropped it, did I give it any initial velocity? Not really. So my initial velocity would be 0 if I just dropped it. Sometimes you'll get a speed given to you. We'll see that in the second one, but sometimes we're going to be given this. So you're like, okay, so now what? Now we're going to plug in our values. So I come back to my equation. I'm actually going to write it out in full here so we can see where everything is going. So I get here, and I go, okay, capital H is 0. Gravity is still gravity. We're looking for the time. How long does it take? So we don't know t yet, but we'll get there. V sub O is 0. And H sub O, my initial height, is 213. Now here's the thing. So now, how am I going to figure out the answer? And here's my answer to that. This kind of looks like something we've been doing before. Kind of looks like when we had A, B, and C, and we did the quadratic formula. That's the route I would go here. So if I need to, I'm going to rewrite the quadratic formula here because I don't want to flip back and forth. If you want to flip, though, it's just on the other side of this paper. And this will be the end when we get here. I've got my A, B, and C labeled. So I'm like, all right, you're like, Hardy, can I do -0? Not really. We're not going to attempt -0. That's a... Because we're trying to figure out this t value. We're trying to figure out how long this takes. And so if I plug it all in the quadratic formula... Now, at first, this kind of looks complex. It's not bad, though. As we have said before, we're just going to work on this part. We're not going for the whole thing at once. And as we have mentioned before as well, second and x squared will get you the square root, so I'll mention that over here. And I'm going to type in everything exactly as I see it, parentheses and all here. But so sometimes if this capital H value isn't 0, if it was some other number, let's say like 6 or something, I'd have to subtract that over first. I have to have equals 0 before I can use the quadratic formula. So...
Could we have even used the 8? Have we?
Yeah, the HO is this 213. It's in here. Yep. And so I get here, and I'm like, okay, so 0 plus or minus 116, we'll go to 116.8. Divided by -32. And you're like, ugh, this is looking kind of weird. We're going to split it into 2. Now, here's the thing. When we do this, we're only going to have one answer that makes sense. We're not going to really have 2 answers for these. Oh my, I'm splitting it because we're doing 2 equations. I still got extra copies in the back. Just saying. And remember, I put the parentheses to let the calculator know what order I want things done in. So I start going, and I'm typing this in. So I'm just going to write my answers here for a minute. Then we'll figure out what works and what doesn't. Now remember what it is we're looking for. It's time. How long does it take for this tennis ball to hit the ground? So here, negative time, this would be like we were doing Back to the Future or The Matrix or something. It can't be negative time. That would mean it hit the ground before I ever dropped it. So that makes no sense. The positive number is the one that makes sense, and that's just true. Can't do negative time. We're not doing any time travel here. So just pick the one that's positive when you're doing it with those. That will be the easiest way to remember it. And so when we see the second one, everything is going to work similarly, except we're going to have one extra step. So here, Julian kicked a soccer ball into the air. The initial height, h sub o, of the ball is 1 foot, so there's 1. And the initial velocity, v sub o, is 40 feet per second. I just need the 40. Find the time that it takes for the ball to reach the ground. So capital H is 0. So let's see if we got everything. We're still plugging into this formula. Okay? So, capital H is 0. Gravity has not changed. We are still on the Earth. What's that? Because when it says for the ball to reach the ground, the H is always going to be where I end up. The ground can't go any lower. Unless we're digging. V sub O is 40. Don't lose the T that's with it, though. Plus H sub O, which is 1. So since we hit the ground, we got equals 0 already. We're good. So I just do my A, my B, and my C. And back to the quadratic formula we go. If you want to use X in there, if T is distracting you, you go for it. So the opposite of B, so the opposite of positive 40 is negative. B squared minus 4AC all over 2A. Like we did before, this is the only part for the time being I'm putting in the calculator. I can't do all the other fancy stuff. The plus, minus, and all that other jazz. So second, an x squared, there's my square root. Again, put it in exactly like you wrote it, and that's a minus in the middle. And then we have a negative for the 16. So I make sure everything looks the same. So I'm like negative 40 plus or minus 40.8. And 2 times negative 16 is negative 32. Split them up. Negative 40 plus 40.8 divided by negative 32. Negative 40 minus 40.8. And again, one of them is going to work. One of them is going to be sensible. I don't think it's going to be the negative. That does not seem sensible. Oops, and I got to make sure I'm following my own directions and doing this correctly. And there's my positive one. That's the one that's going to be reasonable. Okay, so the quadratic formula is going to be our buddy on these problems. And again, that's going to complete the notes for the entire unit. So I will get those posted to Classroom ASAP as well to make sure we're good on that front. Okay, so we're going to be in the practice on pages 7 and 8 today. And we're basically going to go through these. We'll do the first one together, and then we'll kind of see what else we got rolling on the back here. So again, athlete throws a shot put with an initial velocity of 29 feet per second. So there's my V sub O. From an initial height of 6 feet, there's my H sub O. After how many seconds will the shot put hit the ground? You're like, Hardy, is this H over here ever going to be anything besides 0? I don't think we're going to run into any situations today where it is, but we'll double check here in a minute. So now, plug them in. So 0 equals Gravity is still the same. Still hasn't changed. Plus 29t plus 6. A, B, C. And well, I got my quadratic formula on my sheet, so I'm just going to kind of roll here. So, the opposite of B, opposite of positive 29 is negative 29. Square root of B squared minus 4AC all over 2 times A, which the next question might be hardy. We keep getting negative 32 on the bottom every time. When we're doing these, you will, because every time, because gravity isn't changing and that 2 is the same in the formula every time. So, let's get this cleaned up. So we got 29. What's that? Gravity, when we're talking in feet, is always negative 16. And I don't think we're going to get into meters in this class. That's another Algebra 2 thing. Ooh, it comes out nice. 35. Okay. So negative 29 plus or minus 35 over negative 32. And if you know what you're plugging into the calculator when you're splitting it into 2 and you don't want to write this last step, I get that.
We just write the answer.
That's fine. You can go to that as long as you are getting things right. So like here, it's like negative 0.2, but we know that's not going to be right because negative makes no sense. But 2 does.
So what if we didn't even try the negative one and we just went to the right one?
If you can visually see which one is going to be the one that works and you do that, that's fine too. So, but again, otherwise the process is just labeling a couple of points, knowing your A, B, and C, and plugging it into a formula that isn't going to change. So that's not going to be a bad thing. Trying to see how that works. So you're like, okay, 2 and 3 look like that. Let's see what else we got as we get to the back here. 4 and 5, okay, same thing. Ooh, what's this though? What's this 6th thing? The width of a high school soccer field is 45 yards shorter than its length. Okay, minus 45, got it, okay. Write an expression for the area of the field. Do we remember, how do you find the area of a rectangle? Okay. Area is length times width. Okay. So, here's my length and my width. So, L times L minus 45. I'm going to actually distribute here, though. Technically, that would be fine. But for our purposes, I think we're going to need a little help here. L times L is L squared. L times negative 45 is negative 45L. Okay. Here's why we're doing this. The area of the field, A, is 9,000. Find the dimensions. So if I plug in 9,000 for A, and again, if you don't like the L's and you want to use X, that's fine. This has got to be equal 0, because that's how we've been doing these all along. Now notice, my 9,000 doesn't have an L, so I'm not combining it completely with either of these. It can hang out over here, though. Because once I have that 0, there's my A, there's my B, there's my C. It didn't look like the other problems, but I can do it the exact same way. So, Here we go again. Let me see if I can get my quadratic formula up here. All right, there we go. So the opposite of b, the opposite of negative 45 is positive. Square root of b squared in parentheses. Every time, I need to even do that on mine here. Minus 4ac. Ooh, that's going to be a big number. All over, not negative 32 this time, 2a. There's our first thing to deal with. The radical, the square root, is always the place to start. And again, details. Make sure we get everything typed in right. Okay, 195. So, 45 plus 195 divided by 2. Because 2 times 1 is 2. That's where my 2 is coming from. Or 45 minus 195 over 2. Because again, we got this from our radical here. So the nice thing is we know negative 75, I don't think the length of anything is going to be negative 75. But we're not quite finished at this point. This tells me this. Okay, so my length is 120, but my width is 120 minus 45, or 75. That's my dimensions. Even if you just drew it on there and labeled the picture, that's going to be fine. And since this is my last normal video before final review, I can say this one last time. I have about half of you right now. So for half of you, you're going to be able to knock this out when we get to the last quiz. And the other half, you're going to figure it out as you go along in life. That spacing off to the electronics just makes you slave to them. They are your master. And at some point, hopefully, you will figure that out. So,